Hello, students of class 9 and class 10. In both of your classes, you will have the same topic, which is known as percentage composition. In class 9, it will be in the language of chemistry part. In class 10, it will be in the mole concept and stoichiometry chapter. Now, the main thing here is what is percentage composition and why it is so important. It will help you to understand about the empirical formula and other things in a molecule. Percentage composition is actually being taught in class 9 so that you can get an idea about the percentage of an atom in a whole molecule. How you can understand it very easily. You can think that if you have, suppose in a bus, or in a car, if you are traveling 4 people, suppose there are 4 people sitting in a car. Now, the whole overall weight of the car will be because of the engine and other stuffs which are already present in the car. Along with that, the 4 persons who are sitting in the car. One person weight will be different from the other persons. Okay, so the percentage of all the 4 people will not be 25% each. So what are their contributions? What are the contributions to the overall weight of the car? That is what percentage composition is about. Okay, in this case, the percentage composition will be for an atom in a molecule. So here, what you have to do, you have to find the percentage composition. Whenever you will find the percentage composition of an element, okay, percentage composition of an element in a molecule, you will do that weight of the weight means here the atomic weight of the element over the gram molecular weight of the element, GMM, gram molecular mass or gram molecular weight of the molecule. Okay, overall molecule times 100. This is how you will calculate the percentage composition of an element in a molecule. This is the formula by which you can calculate the percentage composition of an element. Now, this percentage composition will vary. This will be the perfect formula for class 9 students, but when we're doing the same thing in class 10, there will be something else, like percentage composition of the water of crystallization. Means suppose you have CuSO4 dot 5H2O. Okay, now you have to consider the percentage composition of this water of crystallization that is there. Okay, so here you will do what? First of all, the percentage composition of water. Here it will be very simple that you have 5H2O, so 5 times the molecular mass of water, 2 into 1 plus 16, okay, divided by the total gram molecular mass of CuSO4 dot 5H2O. Okay, times 100. This is how you will calculate the percentage composition of water. It's very simple and it's very easy for you to do it. Okay, now this is from one side. The next side is, suppose they have asked you, they have given you a lump sum amount, but suppose they have given you CaCO3. Let us take an example of CaCO3. Why CaCO3 is taken as an example? Because the whole gram molecular mass or the molecular weight of this molecule is 100. Calcium is 40, carbon is 12, and each oxygen is 16. So 16 times 3 is 48. 48 plus 2, 50, 10, 60, and 40, 100. So total gram molecular weight is 100. Now suppose they have given you like 20 kg of calcium carbonate. Okay, 20 kg of calcium carbonate. And from this 20 kg of calcium carbonate, they have given you the percentage purity. The percentage purity is only 80%. Okay, percentage purity is 80, means 80% of the 20 kg of CaCO3 is pure. Now you have to find out how much percentage of calcium is there. Okay, how much percentage of calcium is actually there in calcium carbonate. Okay, what is the percentage composition of calcium in 20 kg of calcium carbonate, which is 80% pure? So this is a very simple thing to understand. Now, if you take 100% pure calcium carbonate. So for 100% pure calcium carbonate, okay, for 100% pure calcium carbonate, CaCO3, you will have, suppose 100, you are taking only the molecular weight. Okay, when we are taking only the molecular weight, so it is 40 over 100 times 100. So it is 40%, the percentage for 100% pure calcium carbonate, percentage composition of calcium is equals to 40%. Okay, percentage composition of calcium is equals to 40%. Now, if it is 80% pure, if it is 80% pure, so you do not have to go for this 20 kg and other things. You just have to do for 100% is 40%. So if it is 80% pure, 80% pure calcium carbonate, so it is 40 over 100 times 80. 40 over 100 times 80. So this is a very simple way, simple thing to understand that you are doing an unitary method. You are just performing an unitary method to get your answer. For 100%, it is 40%. For 100% pure calcium carbonate, you will be having 40%. 40% will be your percentage composition of calcium. Now, if you're coming down to 80% of pure calcium carbonate, it will be just a unitary method. If it is 100% for 40, so 1% 40 by 100 and 80% 40 by 100 times 80. So from here, you can easily undo and you will get 32% pure. Now, how will you verify that whether whatever we are doing here in the unitary method, it is actually correct or not? How will you verify it? So for verification, it is also, so as we have taken calcium carbonate for the ease of our calculation, okay? We have just taken calcium carbonate for the ease of our calculation. So for calcium carbonate, let us take, we have given 20 kg of calcium carbonate. We have given 20 kg of calcium carbonate of 80% purity, okay? 20 kg of calcium carbonate of 80% purity. Now, you will write here, therefore, pure calcium carbonate equals 20 times 80 over 100 kgs. That is only 16 kg of pure calcium carbonate. Okay, so in 100 grams of CaCO3, we have 40 grams of calcium. Okay, in 100 grams of CaCO. So what you are doing here, you are just finding out what is the amount of calcium. What is the amount of calcium in this 16 kg of calcium carbonate? What is the weight, overall weight of calcium in this 16 kg of calcium carbonate? So here you are writing, so 100 gram of calcium carbonate, we have 40 grams. So for 1 gram of calcium carbonate, we will have 40 over 100 grams of calcium. Okay, therefore for 16 kg means 16 times 10 to the power 3 grams of calcium carbonate, we will have 40 divided by 100 times 16 times 10 to the power 3 grams of calcium. So from here you can see that if it is 1000, now you will get here 40 times 16 into 10 grams of calcium. Okay, so sorry. Okay, so this is the overall amount, 40 into 16 into 10 grams of calcium in this sample. So you will write here, the sample has this much amount, sample has calcium, the sample has calcium of this much grams. Okay, the sample of calcium has this much grams. Now, in the question, they have given you 20 kg of impure, means 20 kg of calcium carbonate. Okay, so you will write here, when we are doing the percentage composition, so percentage composition of calcium will be equals to weight of the calcium in the overall, means now you are calculating calcium in the overall 20 kg. Okay, because 80% was pure, so 16 kg was the pure calcium carbonate, and pure calcium carbonate will have pure calcium, the other parts will do not have any calcium in there. Okay, so this is the grams of pure calcium in 20 kg of calcium carbonate. So percentage composition of calcium in 20 kg sample, in 20 kg sample of calcium carbonate. So we are just verifying it, that whether it comes to 32% or not. So you're writing here 20 times 10 to the power 3 grams, because 1 kg is 1000 grams. 1000 means 10 to the power 3 grams. So times 100. Okay. So you will do the same thing here. This is 0. This 2 will get cut off like this. This will leave move, and it will get 8, and 4 8s, it will be 32. 32%. So whatever calculation we have done previously is equal to the calculation that we are bringing in this question. Okay. Now let us solve a few questions. Okay. Let us solve a few questions. We are doing this. So suppose they have asked you to calculate the percentage composition by weight of carbon in carbon dioxide, sodium in sodium carbonate, aluminium in aluminium nitride. So they have given you different questions. So we can do any one of them. Let us do with sodium in calcium carbon in sodium carbonate, nitrat. Okay. We can do carbon in carbon dioxide as well. Anything we can do, any one of that. Let us take calcium in sodium in sodium carbonate. So percentage composition of Na in sodium carbonate is Na2CO3. Okay. So in Na2 you have 2 Nas. So 2 into 23 gram atomic weight of sodium is 23 divided by, you will get 2 into 23 plus 12 plus 3 into 16. Okay, this much amount of grams times 100. So you will have 46 divided by 46 plus 12. It will give you 58. 58 plus 48. Okay, 50 plus 40 is 90, and 16 is 106. Okay, times 100. So likewise, you can, I'm just using the calculator for easier to do the calculation. 46 times 100 divided by 106. So it is 43.39. It is coming as 43.39. It is coming. So you can also change it to 43.4. Okay. So let us see what that holds. So 43.4 they have given. Okay. Now let us do another question. Yeah, this is a very good question of 90% purity they have given. Calculate the question number 4. Let us do question number 4. Calculate the percentage of pure aluminium in 10 kg of aluminium oxide of 90% purity. Calculate the percentage composition of pure aluminium. So you can also do this. This is question number 1, so part B, I think. This is question number 4. You can do the same thing. You have aluminium oxide. Okay, you have aluminium oxide of 10 kg with 90% purity. Okay, so you just have to do the unitary method, that is 100% pure Al2O3 has 2 into aluminium. Aluminium is 20. This is 13, 27. This is 27. 2 into 27 divided by 2 into 27 plus 3 into 16. Okay. Times 100. So 2 into 27 means 54. 54 plus 48. 54 plus 48 means 102. 50 plus 40 is 90. And 108. So we coming as 102. So 2 times 27 divided by 102 times 100. So 100% of pure aluminium oxide will have this much percentage composition as percentage composition of aluminium is equals to this one. So the sample has 90% purity, so they have given 90% purity. You can do it right from here. 90% pure Al2O3 has percentage composition of aluminium equals to 2 into 27 divided by 102 times 100. Now, as you are doing unitary method, so you will be dividing it by 100 and times 90. So this 100 will get cancelled. So you will get 2 into 27 divided by 102 times 90. So this will be your percentage composition. Now, let me do it in a calculator. So 2 into 27 gives you 54 times 90 divided by 102. So you'll get 47.647, 47.647%, or you can round it off to 47.65% as well. Okay. I think it is clear to you. Oh, they have given you 64, so you do not need to do it. So I think it is 2 into 27 was 48. Yeah, it's 100 into all the calculations are correct. So likewise, you can do the calculations and you will get this. You can omit this part 647. In the book, they have given you 64, so you can keep it at 64 as well. Okay. You do not have to change it to 65. Okay. So this is how you will complete your percentage composition. If you want to do the other questions as well, like this, you can also do. Now, there is another question in question number 8. Another question in question number 8, you can see hydrated calcium sulfate contains 21% of water of crystallization. Calculate the number of molecules of water of crystallization X in the hydrated sample, hydrated compound. So hydrated calcium sulfate, they have given you 21% water of crystallization. Okay. So hydrated calcium sulfate, okay, has 21% water of crystallization. Understood? 21% is the water of crystallization. So what does it mean? It means that whenever we have done in our previous, whenever doing the definitions part, we have done that percentage of water of crystallization, percentage composition of water of crystallization, is equals to, you have the number of molecules of water times 18. I'm writing it directly. 2 hydrogens and 1 oxygen, 16 and plus 2, it will give you 18, plus the molecular weight, the gram molecular mass of CaSO4 dot XH2O times 100. Okay, so this is the percentage composition, and the question it is given, it is 21. Okay, so you have to find the gram molecular weight of CaSO4 dot XH2. You just have to find the gram molecular weight of CaSO4 dot XH2. So how will you find it? The main challenge for you is to find out the percentage composition, the gram molecular mass of calcium sulfate dot XH2. To do that, to figure out the value, to understand the value gram molecular mass, you are having this data with you, 21% of water of crystallization. So if 21% is water of crystallization, so the that means remaining part, which is 100 minus 21% or 79% is CaSO4. Okay, if 21% is water of crystallization, then 79% is CaSO4. So we will write 79 now. We will come to this part in a while. Let us first do this. According to the question, 79% of CaSO4 dot XH2O weighs, what is the weighs? Ca is 40, sulfur is 32, and this is 4 times 16. Okay, weighs this much grams. So 416 is 64. 64 plus 40 is 104. 104 plus 2, 106 plus 30, 136. So 79% is weighs 136 grams. So if 79% weighs 136 grams, therefore you will write 100% means just the unitary method of CaSO4 dot XH2O will weigh 136 divided by 79 times 100. This much amount of grams. Okay, this much amount of grams. Now, if you are doing this in your exam, you will find it very difficult that 79 is a prime number. Okay, that means none of them will get cut by 79. So what you can do here is you can convert 79 to 80. Okay, you can convert 79 to 80 and that will not make much of a difference. Okay, you can convert it 79 to 80 to ease your calculation. But whenever you are converting it, you will write here approximation. Okay, you will write here approximation and you can do it in the rough as well. You can do this, means basically it is advisable to you that you do this in the rough side. Okay, and when you are writing the answer, you will write that this will approximately valued to that part. Okay, so ultimately you will get the right answer whenever you're doing, because you're just converting 79 to 80 to ease your calculation. So you will get this. Now it will be 4, it will be 5. Okay, so you may not also cancel this part. Okay, you can also do this. 2 6 are 12, 1 6 16, 2 8 are 68 is 136 divided by 2 is 68. Okay, now 4, you can directly cancel 68. 4 ones are 4 and 2 8, it will be 17. Okay, 17 fours are is 68. So it will be 170 grams. So approximately 170 grams. Whenever you are doing this, you have to write here approximately 170 grams. You do not have to go for the accurate one because you have already given here this approximate sign. You have already given here the approximate sign. So it is 170 grams. Understood? So if 100% means this is a molecular, so therefore GMM or gram molecular mass of calcium sulfate dot XH2O is approximately equals to 170 grams. Now put this value here. Why did I left here? Put this value here. 21% X times 18 divided by gram molecular weight. What we have calculated 170 times 100. Okay. Now it is X will be 21 times 170 divided by 18 times 100. Okay, so 3 sevens are 3 6. Now you will have this much 17. You can do it. 17 times 7 is 49. And this is 717 plus 4, 11, 119. We're getting 119 divided by 60. Okay, 119 divided by 60. So you can see that it is it will be approximately 2, which is 119. So if it was 120, then you could have got approximately 2. So this will also, if you do it, if you do the math as well, you will get approximately 2. Okay, so this is got from our got from the later calculations. Okay, got from the later calculation as this. So this is how you can easily find it out. Now you got the value of x. You got the value of x as 2. You just go and check here. It has given you the value of x as 2. So this is how you can easily understand and easily do this type of questions. I think it will help you in your classworks and your homeworks and understanding the questions. If you're in class 9, it will build your foundation for class 10 when you will be going to class 10, and all things are for ICSE, because in CBSE percentage composition is not that much here. But if you are in CBSE as well, this topic will help you to understand that whatever we are going to learn in class 11, because in class 11, in the chapter stoichiometry, you will have a first chapter, which is also some basic concepts of chemistry. Here, there is an extension part of the stoichiometry chapter of class 10. In ICSE, it is there. In class 10 also in CBSE, there is a chemical equations chapter. There are also some equations of calculations like this you may face. Okay, so all the things are unitary method and everything is very simple and very easy. You have to just understand the questions and you have to understand what they want from you. Okay, and everything is given in the question. Everything will be given in the question. You just find the hint and do it accordingly. Okay, with that, I take your leave. And if you find it helpful, then you can subscribe, or you can like it and share and do everything. If you do not, well, you can also comment also whatever you want to know extra, and also I can find that and I can help you with that. Okay, so for now, bye bye.